evening to everyone, depending on the time zone you're actually logging in from. Once again, welcome to the AWS APAC Webinar Week, and thank you for joining this session on AWS MySQL, the Relational Database Service, Best Practices for Performance. So just to introduce myself, I am Robbie Thomas. I'm a Solutions Architect with AWS. And I just want to reinforce one of the things that Chris mentioned. So during the duration of the talk, you can input your questions into the chat window. We have a panel of experts reviewing all the questions, so you don't have to wait till the end of the webinar to actually ask all your questions. You will get your replies, and we'll also have some time in the end to pick out some of the questions and answer them as well. So let's get started with what's new. So at Amazon, we see a very fast cycle of deployment of newer services and features, and RDS also keeps up with the same clip. So some of the services that were released specifically for Amazon RDS for MySQL are on screen. So we released encryption using customer managed keys, which leverages the AWS key management service. We have increased the maximum database size possible on MySQL RDS to 60 terabytes. So people who are already using RDS for a long time, you would remember that there was a time when the max size was a terabyte. So that's increased to 6 terabytes now. We have a far more simplified reserved instance pricing, which is more aligned with the EC2 pricing as of today. So you can actually give a full upfront, partial upfront, or no upfront instance reserved instance pricing. We also allow customers who have HIPAA compliance requirements to be able to get that compliance and still leverage the RDS service as well. We also announced in preview the AWS database migration service at our annual customer event, reInvent, a couple of months ago. It's still in preview, but we will talk a bit more in this talk about migrating your databases to RDS. Okay, so with that, let's have a look at some of the customers that are already using RDS. You can see we have a variety of customers, all the way from enterprises like Samsung and Vodafone to startups like Airbnb. But for people who are just starting out and are exploring whether they should use RDS, why do you want to choose Amazon RDS? So some of the things that RDS takes care of you, it takes care of your database, is basically high availability, backup and recovery. So if you look at your database service, right, it's one of the most important components of your application. It is a stateful service, and I've been a database administrator myself. So if you take any mission critical application, you want the database service to be highly available all the time. If you are a DBA, many times you would be asked to actually restore a database from probably a previous time because of some transactions going wrong, and you want to actually restore the data to a point in time so that you can actually analyze at how the data looked at probably maybe last night at 10:30 p.m. so that you can actually your business analyst might want to actually see what actually went wrong with my customer transaction, right? So previously, doing all of that was intense DBA intense task. The database admin would have to actually restore a full backup and then apply transaction log backups till they get a point in time restore. There are other things also that RDS takes care of, like push button scaling, which is something kind of unknown in the traditional world where you run on-prem. Because if you had a database running and you actually wanted to scale up the database, it was a pretty intense task. You actually had to order hardware, you had to order heavier hardware, and then actually do an entire database migration process. But in RDS, you can actually scale the database with a click of a button, and you can scale it back down after your requirement comes. And that kind of aligns with a lot of customer requirements that we see, because many customers have varying loads for their actual workload. At the planning for peak for the database capacity is usually a waste of resources and a waste of money for which has variable workload. So RDS takes care of a lot of other work that is there in the database, or I would say undifferentiated heavy lifting in terms of patching, in terms of monitoring, in terms of routine maintenance, and so on and so forth. And what does this allow you to do? It allows you to focus on your application. And that's where you actually have differentiate yourself, right? So you want to focus on schema design, you want to optimize your queries, you want to write better queries, and and basically add more functionality to your application. Right? So, Amazon RDS actually has provided many features, to give you high availability, cross-region replication, and so on and so forth. And we'll get into a little bit of these details. So one of the most important features that is actually given is high availability with multi-AZ deployments. So you can consider, so people not familiar with the AWS AZ or availability zone concept. Basically, availability zones are physically separate data centers or clusters of data centers with various factors of separation. Like they have redundant power, they are not on the same floodplain, they are not on the same fault plane. In case of an earthquake, they have redundant personnel. A lot of design considerations have been taken before choosing these availability zones, and each region has 2 or more availability zones, and usually it's at least 3. So when you deploy an RDS instance in multi-AZ mode, you actually have a synchronous copy of your primary database in another AZ, and that is a separate physical data center. Okay, so many times you would see high availability done within a single data center, and your data center is always a single point of failure if you want to consider the entire data center. But if you're deploying your RDS in a multi-AZ mode, the data center is redundantly, your data is actually redundantly copied across 2 different availability zones. And we see that customers have come to really like the multi-AZ feature. This data itself on the screen is actually close to a year old. Right now, the number of customers or the number of RDS instances using multi-AZ is close to 50%. And some other features that also come that are very useful to customers are one is using cross-region replicas, which allow customers to build multi-region or cross-region disaster recovery. So you can actually have a read replica in a different region altogether and have copies of your application there as well. So you are assured that even if there is a regional failure, which is which is probably very remote chance of happening and has never happened in the past, because an entire region failing means multiple availability zones going down. But just in case that happens, if you want a copy of your data in a different region, it's just a push button. You can actually create a read replica in a different region. You can, apart from that, you can also take snapshots of your database at point in times, and so you can, so it's a consistent snapshot of a database which is actually stored in S3 storage, in Amazon S3 storage, which is actually highly redundant storage that stores data across multiple availability zones. And you can also copy those snapshots itself across regions, and incremental copies of the snapshots. So if you take one snapshot copy, it will copy the entire database, but after that, incremental copies or it's incremental data that actually is transferred in a snapshot copy. So your data actually is copied to S3 in another region, and that has actually far higher durability as opposed to having a read replica. So it's useful for scenarios where you want a warm standby for disaster recovery, and also you want, so you're okay with a little time or with a higher RTO or recovery time objective. Basically, you're okay with actually a few hours of time to recovery, but you want a highly durable copy of the data in another region. Right. So let's move on to database migration. If you're not on RDS, if you're on either EC2 or you're on an on-prem server, there are a few strategies that you want to take to actually migrate data to RDS. So let's see how we can actually import data from an external MySQL source. So this is a typical app, and you probably have a master. You can actually take a backup of the database from the master DB, or even better, you want to import data from the database slave, right? And you want to actually transfer that backup to a staging server in AWS. And this can be as simple as actually using SCP into a staging server, and staging server can be any EC2 instance. Right? And after that, you can actually spin up an RDS instance and load the data from the staging server. You don't want to load the data directly from your on-prem. It's better to actually stage it in the staging server, so that because there'll be high latency between, there'll probably be high latency between your on-premise database or your on-premise data and you want to move that backup and leverage the low latency that is there between EC2, the EC2 instance or the server on either Amazon and RDS. And after you've loaded the data, you can actually map it as a slave to the master database, and later move your application also to AWS and change the database from to be a master, so that you're making it into a read-write mode as well, and your application is flipped over to the AWS region using RDS as the backend database. So a few things to consider here. You want to take a backup from a replica or a slave so that you don't load your master database. Always compress your backups. MySQL backups are typically text files, so you can actually compress backups and so that you can transfer the file faster using methods like SCP, or you can also use other TCP, UDP-based file transfers like Tsunami UDP or Aspera. Use a staging server in EC2. We talked about it in the last slide. And also, wherever possible, use a primary key sort order so that there's not a lot of reorganization of data while you're actually loading it, and your data load times are actually lower. Some considerations for your target RDS instance. Launch on a bigger instance. Have an instance with more memory, more IOPS, so that you can actually load data faster, so that it lowers your overall migration time. But and you can always scale it down later after you have loaded and you've done your benchmarking and stuff like that. Disable multi-AZ because at the time of loading, because multi-AZ copies data synchronously to another data center. So you want to basically remove all. So while multi-AZ is fine in a normal OLTP scenario where your transactions running on the database, when you're doing a bulk load like a DB migration, you want to disable multi-AZ. You want to disable binary logging as well. So you basically don't want to have logging hit. Basically, if you're going to do logging, it's going to hit the disk for every single transaction that you're loading. So you want to set the InnoDB flush log at transaction commit to 0. Basically, you're not committing anything to the database, which is fine because you're not actually looking at doing a crash recovery on this instance. You're just migrating data to a new instance, so it doesn't need to be fully crash compliant. Also, you can also set auto commit to 0 because you don't want to actually do auto commits for all statements, because commits are expensive, right? And you can also set checks for unique and foreign key constraints to 0, because your data is coming from an existing relational database where all these checks have already been done. You don't have to actually do those checks each time you're loading data. So each time a row is inserted in a table, you don't have to check if that foreign key exists or not, because it's already compliant. So you can load data in a couple of input formats. One is you can either do a normal MySQL dump and then load data. But the problem there is that you're basically just doing you're applying DDL and DML or data definition statements and data modification statements directly. It's more, you can also load flat files. So the SQL execution could be slow. You're basically just replaying all the statements that could recreate the database. And also, since it's sequential, it's slow. And if you fail anywhere, you need to restart from the very beginning. It's okay for smaller databases, but once the database gets into hundreds of gigabytes, you probably are better off using flat files. Using SQL input can be simple, but using flat files are a little more complicated, but you definitely get a lot of scale if you're actually loading data from flat files as well. So how do you, so now you have done a full MySQL dump, and then you have moved the data, you have a copy in the RDS. You basically have your data exported and imported into an RDS instance. Now you would actually create a replication user using the commands in MySQL and give it permission to read from the master. So you would, and there are various RDS stored procedures that are available. You can see some of the stored procedures on the screen, like RDS set external master, etc., which you can actually set to configure replication, the replication target. So right now your master is on-prem and your slave is an RDS instance. And whenever you feel that your application transactions are the lowest, probably on a weekend, in the middle of the night, or at any time according to your business, if the transactions are low, you can actually take a pause for the application and stop transactions to the master, and then call these next commands, say like RDS stop replication, RDS reset external master, which you can also use MySQL commands, but RDS has a set of stored procedures that kind of help you to actually get it done in a slightly more easier fashion as well. Now, you might also want to export data to an external source. So there are various reasons you want to do that. One is you might want to actually export data to share it with another partner who actually is doing their testing on-prem. You might want to actually get a copy of production data to refresh your development or test databases on-premise to get a fresher copy of the data. So you can do that as well. So you can actually take a dump onto a staging server and do a SCP back into your own data center. Excuse me. If you want a more recent copy of the data itself, and also on a more continuous basis, you can do that as well. RDS allows you to actually run a master-slave configuration, which is kind of the opposite of what we were doing earlier, where we had the master on-prem and the slave in RDS. You can also have RDS as a master and a slave on-prem if you want to do so. And there are stored procedures that easily allow you to actually achieve that as well. Please note that this is only possible in MySQL 5.6. It is not available in the earlier versions of MySQL. Now, so some of the questions that we usually get from customers is, many customers are interested in actually running analytical queries against Amazon Redshift, which is a columnar data store used by people who want to do analytics and BI on AWS. So one of the ways possible is to actually have the bin log formatted in a row-based, you turn on row-based logging and extract those bin logs and apply it to Amazon Redshift. Basically, you'll be firing insert commands onto Redshift, but I wouldn't really recommend that because the best, most efficient way to load data into Redshift is to use the Redshift copy command. You can, so if you don't want to get into internals of actually moving data to Redshift, you can also use the, if you don't want to do it yourself and you want a partner solution, there are partner solutions from Infinity or Fly Data that actually allow you to do that, and that I would recommend that a little more. We have just announced the AWS database migration service a couple of months ago. It's still in preview. So this supports different kinds of migration scenarios. It supports homogeneous migration, so migration from an on-prem MySQL or Postgres or a SQL Server or Oracle to AWS, to a RDS instance in AWS. It also supports heterogeneous migration. So heterogeneous migration kind of helps to a good extent. There would be still some work to be done. It may not be that seamless, but it would take care of a lot of the heavy lifting that has to be actually done. So this is still in preview, so I'd encourage anyone who's interested to actually sign up for the preview on our RDS website. So let's move on to availability and disaster recovery, which is one of the most important areas with which actually RDS helps you. So we have, right, so this is a pictorial representation of that. So you have the application talking to a primary database, and then you have a physically synchronous replication to the second AZ. And for people who are concerned, if the fact that it's a different data center, what will be the impact of the synchronous copy? So even though the data centers are physically separate, the availability zones are physically separate, they actually are connected by private fibers, so they have very low latency of close to a millisecond. So it doesn't really affect the transaction. You can do a synchronous copy to a secondary data center. So the multi-AZ deployment is a copy to a secondary to a second AZ, and the application at runtime talks to the primary instance. But if there's a failure, it roughly takes around 25 seconds to detect that failure. Right? And then we promote the standby, which roughly takes around 5 seconds. And then we update the CNAME, or basically when you create the RDS instance, we actually create a CNAME or a DNS record, which is what you would actually input in your connection string in your application. And this DNS is actually updated, and that roughly takes around 30 seconds for the DNS update plus the crash recovery, which is basically the application of the latest log. And that update, so overall, roughly a minute for the entire failover to happen. And what the CNAME enables you that you don't have to change anything in your application. Your application, you can actually configure application to do exponential backoff, basically show a friendlier screen to the end user, and while so it will probably take around 60 seconds, and you will feel like it's your customers will feel like it's a seamless failover, right? And as soon as we failover, we actually create a secondary copy again. So your multi-AZ is not does not become single AZ in terms of in case of a failure. It actually goes ahead and the RDS service goes ahead and creates a secondary replication immediately after that on a different instance if the primary actually fails. Right. Let's quickly go to read replicas. So you can actually create read replicas. Read replicas are not synchronous like in multi-AZ. They are async replication. So you want to send your eventually consistent reads to the read replica, and but if it is any if it's any data that needs consistent read, you don't want to send them to the read replica. Right, so your writes still go to the primary, and all your reads, some of your reads can actually be redirected to the read replica, and it can also be used for scaling. We'll talk more about that. So even if your primary fails and you will fail over to the secondary. So the read replicas actually in RDS in MySQL 5.1 and 5.5 actually fail in that scenario, and you will actually get an error if you're on MySQL 5.1 or 5.5, because basically when RDS or MySQL does a master crash recovery, it starts new bin log, and the slave is still trying to process data from the older bin log, right? And that actually is a problem. So this has been sorted out in MySQL 5.6. So even if there is a failover of in multi-AZ, you don't have to do anything with the read replica. If you're on 5.1 or 5.5, then you basically have to delete your old read replicas and create new ones. So that's one thing to keep in mind. I would recommend anyone on 5.1 or 5.5 to actually migrate to 5.6. We do give a push button migration feature to MySQL 5.6, which really has a lot of great features as well, and that's what we see most customers actually. You can also see that MySQL 5.6 is far more performant than MySQL 5.5 as well. A lot of performance improvements. Really encourage you to actually migrate to the latest version. You can also do a disaster recovery using read replica. So while you have a synchronous multi-AZ copy on-prem, you can also have a read replica in a different region itself. And we talked a little bit about that earlier in this slide. So you can have a cross-region DR strategy. So even if your entire region goes down, your application can fail over to the secondary region. Let's move on to more about scale and performance. So a few things to keep in mind over here. So your primary, if you have a single instance and you're right, so typical OLTP application read to write ratio is 90-10 or 80-20. And if that's a scenario, basically you can have writes and 10% and the remaining, the rest of the entire database is, or the instance is available for read traffic. But suppose you want to scale the database. Like if you want to scale the database, then you can add read replicas. You can add up to 5 read replicas, and you can spread the reads that are tolerant towards eventually consistent data to read replicas. And you always have some reads that need strong consistency. That will still go to the primary server, right? But as your writes increase, you can see that if you have a lot of writes, right, you can see that you have less room actually for reads. So what you see on the screen is like your scaling factor when you actually have writes. So when you have 10 percentage of your queries are, if they are writes, you can actually scale far more. But as your writes get higher and higher, and you're reaching close to 50%, the amount you can actually scale using, or the number of transactions per second you can scale to using read replicas is kind of diminished, because the read replicas are also taking a lot of, they also, you also have to write data. The read replicas also have to write all the changes that actually happen. This is kind of mitigated in Amazon Aurora, which is fully MySQL compliant database service from Amazon. So you can actually take your code in MySQL or running on my RDS MySQL, migrate those stored procedures and SQL statements, and as well as the data to Aurora. And Aurora is also supported by the database migration service. So this issue of read replica having less performance with higher writes is actually not there in Aurora, because of various changes that have been done in the backend Aurora engine. Another feature you want to consider is using InnoDB cache warming. Basically, this saves the state of the buffer pool onto disk, so that the application can respond faster after a DB restarts. It's usually during restarts that it actually helps you. So you have far better performance. So the buffer pool is loaded into memory, and then it's at time of restart, it's basically flushed into a disk. So you can see the difference over here. So at the top, you can see an instance with warm cache, and the bottom blue line is actually an instance with unwarm cache. So it takes roughly around 9 minutes for the instance with unwarm cache to reach up to the transaction levels that instance with warm cache actually can help you. So you're getting roughly 4x performance even for that short duration. So 9 minutes may or may not be short duration depending on your workload. More often than not, I've seen customers saying, I want to be back and perform as soon as possible. You can configure that in the parameter groups in RDS. So you can actually say, InnoDB buffer pool dump at shutdown, and InnoDB buffer pool load at startup. You can set those values to 1, and it will actually do InnoDB cache warming for you. Right? So suppose you have InnoDB cache warming for unplanned failure. How do you handle that? Because this only handles it when you have planned shutdowns and starts. So you can actually create an event that actually basically dumps the buffer pool into disk every 1 hour or so that you can have the cache ready up to the last hour, which kind of also helps a lot when you want to recover from a crash. So coming to schema changes, a few considerations here. You can use multiple methods to actually do schema changes. For people familiar with MySQL and database in general, the schema changes are usually the most heaviest hit. They are one of the most intense operations, especially if you want to add a column to one of the tables. And if it's a small table, it's fine. But if your table has a few 100 million records, that can be a pretty intense operation, right? So you can actually create a read replica and have only read-only queries hit to your primary, so that no transactions are actually happening on the primary, and then so your application is still kind of up. Especially, if your application So you can have read traffic to your application, but not write, so that you don't want the database to, you don't want the data consistency to be lost. You can apply the column change to you can change your read replica into a read write and then apply your alter column statement to the new database, and it'll run much more faster than running on a transactional database. So you can apply the alter table statement, and then you can make that your master, and then have an application point to this new read replica database. That's one of the ways, and you can actually delete your earlier RDS instance. So it's pretty easy to do, but basically there are some other ways in which you can do that. You can use the Percona toolkit, so you can use PT online schema change as well to change the column, to add a column while the database is running. But this has to be done on EC2. It cannot be done on RDS. You have less performance impact, but it actually takes more time. So you see over here that if you do native 5.6 alter column, your performance takes a huge hit for some time. But if you use Percona, you take a slight hit, but it's for a far longer duration. So you have to weigh your options to decide which one you actually want to use to do, which method you want to use to do alter columns. Now, two interesting instance types that were released a while ago is GP2. GP2 is a EPS storage, and we have the T2 instance type. So GP2 storage actually is burstable storage. So if you see storage, right, you basically get two things. You get storage space and you get I/O performance, right? So GP2 gives you an assured baseline of 3 IOPS per GB. So if you have 100 GB volume, you get an assured 300 IOPS for that volume at any given point in time. But when your usage is below 300, say you're using just 100 IO per second, you can actually earn the credit. So the remaining 200 is credited to you per second, and it goes into a bucket. And think of it like a leaky bucket where you can it fills up to a certain level, but after that and it stops there. And you can actually burst. You can burst up to 3,000 IO per second. You can use those credits that you accumulated, and so that actually helps with a lot of bursty workloads. Many applications may or may not need a consistent high IO per second. And in T2 instances, we have the same concept, but it is for it is actually for CPU performance. So you have a base performance, and you earn credits every hour when you're below that base performance, and you can actually burst when you actually need more CPU. You can always monitor your CloudWatch metric to see how much credits that you have for both GP2 volumes as well as T2 instances. So a combination of T2 and GP2 can be pretty powerful depending on your use case. So if you see, you can have very high transactions going on. So the blue line is actually read IOPS, and the orange line is actually CPU utilization. So CPU performance. So you can burst to a high level, and then after a certain point in time, these performance will actually come down as we start capping if you actually burst beyond what was actually allocated to you. So your GP2 has exhausted credits. That's led to lower performance of the application over, and then T2 exhausts your credits. That further reduces the CPU credits, or basically the number of transactions your application can do. So basically, it brings down the number of transactions itself. So let's see how you would actually evaluate which instance to use. So if you want to, so let's take some of the instances, and this is where using the freedom to actually choose different instance types in AWS kind of helps you a lot. So let's look at a base instance, the M1 instance, which is actually an older generation instance. So if you're going to run on a RDS DB M1 medium instance with 200 GB of standard storage, you can roughly, this is one of the benchmarks we have internally, but you can roughly run around 1,500 transactions at 57.5 cents per hour. But if you go to a newer generation instance with 200 gigs of storage and you have a baseline IOPS, you plan for provisioned IOPS for around 2000 IOPS, then you actually can run more transactions at a lesser cost. So your costs have now come down to for around 40 cents per hour. Right? From there, you can actually try out different instances. So you can actually see that if you go to an M3 large with the same volume, 200 gigs and 2000 IOPS, you actually have increased your cost itself. So you're now at a little over 50 cents an hour. But you really, so that's quite like around 20% improvement increase in price. But the number of transactions you're achieving with that may not be in line with the amount of with the cost that you're actually incurring. Right? And you want to compare that with the T2 medium with the 200 gigs of GP2, and you can see that you can actually do more transactions for a short duration. So GP2 now costs around 10 cents or 10.5 cents per hour, and you can do more than actually what you could do with the M3 large with 2000 IOPS and 200 gigs, 2000 provisioned IOPS. Right? So you can actually do more transactions at a far less cost, roughly 1/5 of the cost, but for a short duration. Right? So what we want to encourage you here is that try out different instances. So let's look at one more scenario which we see very commonly. So suppose you had a T2 medium with 1 terabytes of GP2. Right? You don't have a terabyte of data, but you only have 200 GB in the application earlier. Right? So since you have a terabyte and you get a baseline performance of 3000 IO per second per terabyte, because it's 3 IO per GB. So you get a baseline IO performance of roughly 3000, which is pretty high. It can actually help support a lot of transactions, especially database transactions. Database transactions tend to be IO heavy. You have to finally write the data to disk at some point, right? So if you are over provisioning your GP2 a bit, you actually can get sustained higher performance for long periods of time at less cost than even than actually running an M3 large with 200 gigs. So what we really want to encourage you is that you really want to evaluate different options. T2 is a really good option, and RDS has been supporting T2 for a while now. So you can see you can try out different options so that you can arrive at the right price point for your application's performance, right? So that's the whole idea of RDS. Basically, we want you to let us manage the muck, and so that you can keep your database. You can focus more on your application and focus more on things that actually differentiate you, that actually brings value to your business, and focus on the application and features of the application itself. You can try Amazon RDS for free. There is an Amazon free tier, so if you sign up for an account as of today, you get for your first year you get a free tier, and the free tier is applicable to many other services, including EC2 and S3 and Redshift. So the details of the free tier are available at the link on the screen, and you can run an RDS instance, one of the micro instances for 20 GB of TB instance storage and 20 GB of automated backups and 10 million IO operations per month. You can actually run it for an entire year. But I encourage you to kind of try it out so that you get a feel of how it works. You can get more details of Amazon RDS. Obviously, we do run webinars like these. There's also an Amazon YouTube channel that's available. It also has an RDS section which you can have a look at. There is the RDS homepage and FAQs, and there's a lot of guides for each search engine, for each database engine. You can so there are various engines that actually are supported on RDS, like Oracle, SQL Server, MySQL, Postgres, and now MariaDB is the latest addition to the RDS family. Right? So I encourage you to actually look at general RDS features as well as engine-specific RDS features. That said, so there is the online labs and training. Just want to point out some of the some of the services available so that you can learn more about RDS and all other AWS services in general. So we have online labs and training. You can go to the aws.amazon.com/training to get more details out there. You can also attend instructor-led classes. There is a schedule that is there in the same link below. So you can see which all locations, which all cities are these instructor-led classes, and you can go and attend these. So there are courses for people of different levels. You have, and not only that, you have courses for people who are interested in different tracks. So we have systems operations, we have solution architecture, we have developer-oriented courses, we have DevOps-oriented courses, we have big data-oriented courses. There's a whole variety of courses that are actually available. And last but not the least, there is the AWS certification program, so that you can actually validate your technical expertise of AWS. You can have, you can have a look at the different certification levels. There are different tracks for developers and architects and systems operations guys, and also DevOps guys. So various levels of certification which you can actually take, and all of them are available at the same link below, aws.amazon.com/training. And with that, thank you all for attending. I'll kind of I hope you have been posting questions and have been getting answers. I'll kind of pause now. We'll spend the next 15 minutes trying to go through some other questions you may have. If you have any follow-up questions as well, you can actually email to the AWS APAC marketing at amazon.com email ID. And we do encourage you to actually talk about this event and of the webinars that are happening this week on Twitter, Facebook, and various social media channels. So thank you. Hi, this is Ravi here. I can just want to remind everyone, you can post, the webinar is on for the next 15 minutes, so you can post your questions online into the chat window. Okay, I have a few questions here. So can the DB migration services be automated? Does AWS provide automation template for that? Yeah, so that's the, so I was talking about the DB migration service. So in the duration of this webinar, I spoke about certain techniques you could use as of today and have been used by customers in the past few years. With the new DB migration service, which is in preview as of now, that is supposed to, that will hopefully make it even much more seamless than what I said. So if you can see today's webinar, you have to do a lot of steps yourself. You have to fire some commands and stuff like that to actually do the entire migration. There is some involvement, there is some involvement required from your side. With the new DB migration service, we're hoping to make it more seamless. Which are the databases supported by AWS? So in the relational database service, which is what we are focusing on today, our RDS, we support Oracle, SQL Server, MySQL, Postgre, MariaDB, and we also have our own version of fully MySQL compliant database, but with far more performance is or far more throughput rather is Amazon Aurora. Next question: in disaster recovery, does AWS automatically switch the database on very easy? And the estimated time for switching is 60 seconds. Yes. So if something goes wrong with the primary instance or the primary data center, we will fail over to the secondary data center and secondary instance. Does AWS support Oracle RAC as of now? Is it a workaround? A workaround needs to be done. What is it? So there is more documentation on this. We recently announced support of Oracle RAC using some partner products. I don't have too much details on it. It is slightly different from the RAC that you are used to by building on-prem. If that is a question, no, that's so you actually can build a scale-out Oracle RAC on AWS. Please do send an email to the email ID you see on your screen, and we can get back with more details of specifically how it is supported. How does MySQL licensing work in RDS? Well, MySQL is open source, so you don't need to purchase any separate licenses. All the costs are inbuilt into the RDS service. Okay, next question. What about encryption of data at rest for MySQL data files and backups? What options are available at AWS? Is it possible to use external encryption options like Warmetric, which needs dedicated hardware? So I'm not sure specifically about Warmetric, but basically Amazon allows you to encrypt data in SQL Server, in MySQL and multiple RDS database engines. And MySQL is actually integrated with the Amazon KM as a key management service, so you can actually have a customer managed key, a key that you manage, you create, you delete, you totally manage, and the data in RDS is actually encrypted using that service. Next question: can we check the performance and write configuration of MySQL DB at a particular instance of time? Yes, so we actually expose a lot of parameters like CPU, memory consumption, so on and so forth, and also a lot of DB level parameters. You can check them via the CloudWatch service. You can see a lot of parameters in the CloudWatch service as well, and you can also monitor some parameters from the MySQL prompt. How easily can we integrate Kinesis into RDS? Okay, that's an interesting question. So typically, so for people who don't know, Kinesis is a ingestion service, a data ingestion service. Think of it like a queue or a buffer. If you have a lot of, usually used in massive big data applications where you have ingestion of data, and you want to buffer the data that's coming in so that you don't overwhelm the systems that consume that data. So in Kinesis, Kinesis has a feature called Kinesis Streams. In Kinesis Streams, you can actually read the data from Kinesis using the Kinesis client library, and within the client library, you can actually write your SQL insert statements. You can basically, the servers that run on which the Kinesis client library and your application runs, that has to insert data into RDS. There is another service called Kinesis Firehose, which actually allows people to write to Kinesis, and it directly writes to both Amazon S3 and Amazon Redshift. As of today, it does not support RDS. So for RDS, you'll have to use Kinesis Streams, read off Kinesis, and insert it into RDS database yourself. Next question: are there any migration features from RDS to on-prem DB clusters? So I think I kind of mentioned this during the webinar itself. So if you want to move data out of RDS into an on-prem GP cluster, you can do so. You can actually first export all your data to another EC2 instance and restore it back on-prem, and you can actually set and to get the transaction in between, you can actually set your on-prem database as slave and the AWS RDS instance as master. And then very similar to the process you use to migrate into RDS, right? So the reverse of that, you can do the same thing. Okay, next question. My company uses AWS services on EC2, RDS, etc. Since I'm new to RDS, may I know how I can go about creating master-slave replication on my existing RDS? I have 4 RDS instances running now. Okay, so in RDS, it's pretty simple. You can actually, it's an option in the settings of RDS instance. So you can go to settings and look for an option that says multi-AZ, and by default, it will be no. If your instance is not in multi-AZ, it will say no. You just have to say yes, and then you can say apply. So there's a checkbox that says apply immediately. So if you check that, it will immediately create a master-slave replication. If you don't do that, it will actually take that action in the next maintenance window that you have specified. Next question, can we use the various third-party tools which MySQL generally supports in RDS? So there's nothing specific. You can use pretty much any third-party tool to connect to RDS. So you can use the MySQL Workbench. Anything that's compliant with normal MySQL can be used. Next question, and that's a good one. So assuming AWS RDS automatically updates the DB engine, how do we ensure that our application is compatible with the upgraded DB version? Okay, so there's an option in the RDS console that says auto upgrade for minor patches. If you can actually disable that option. Major upgrades, like for example 5.5 to 5.6, we don't do it without coordination with you. So you need to test the application. So you need to go the dev test production route. So you can make the change in test and test your application first, and till that happens, and you can actually have the upgrade done only when you're sure that your application actually works with the newly upgraded version. So uncheck that box that updates minor patches if you're concerned about even minor patches, and major upgrades we anyway don't do without coordinating with you. Next question. I have a question. To enable read on replica, any configuration need to apply on application? If so, how to configure that? Yeah, interesting question. So so your application should be able to differentiate between read queries that are tolerant of eventual consistency, because the first thing to keep in mind is that a read replica is eventually consistent. It's at least a few seconds, depending on the amount of writes that happen on your primary, it will be at least a few seconds, maybe a few minutes behind the primary. Right? So you need to be able to differentiate that. There are some services and tools that allow you to, which actually parse your SQL statement and send reads to the read replicas, but you have to be very cognizant of the fact that it is eventually consistent. Not all selects are tolerant of eventual consistency. If it's just a WordPress read-only application, you're fine. I mean, you can just use any of those load balancing tools that are available. But if your application is a transactional application, you need to differentiate between a queries, select queries that are tolerant of eventual consistency versus select queries that need strong consistency. So basically, you'll have to do application level changes to achieve that. Okay, next question. Can Amazon Data Migration Service support bulk migrations like on-prem data mart to RDS Percona cluster? So it is still in preview, and I am not sure of the answer to that question. You can send an email to the email you see on the slide, and we will get back to you when we have more understanding of the specific features that are available. So it basically does help you to do migration from homogeneous and heterogeneous migration from on-prem, even for large data sets. So I'll take the last few questions. We just have 3 more minutes. How about licensing for MS SQL in AWS? Is that the standard license which is available with the Windows instances? So yeah, so there is there is Microsoft SQL Server is available in standard edition as well as enterprise edition in the Windows instances as well. You can also do BYOL. I would encourage you to have a look at the BYOL or section in the AWS website where we talk more in detail about it. So what other ETL tools are available in AWS Ingest data to RDS or Redshift? So you can use many ETL tools. You can go to the AWS Partners section, or you can go to the AWS Marketplace or aws.amazon.com/marketplace. There are sections there. There are partners there that actually there are many partner products that actually allow you. So most of the popular industry tools you can use. Informatica as a partner. You can use various ETL tools that are available in the market. Okay, so last question. How much configuration are we allowed to do for MySQL in AWS RDS versus installing and maintaining MySQL in EC2? Yeah, so a lot of the parameters that you would want to change yourself are actually available via the, one of the tabs that are called parameters. So you can set parameters. So for example, DB, buffer cache or things like that. You can actually set in those parameters. It's a very long list of parameters, and it's different for each database engine. So you can, it is available. You will not have access to the OS layer itself. So there are some parameters you can set and some that you cannot. So you have to go. The list of parameters are available in our documentation. So I think time is up, and you please do send any remaining queries that you have to the email that you see on screen.